Hello, my name is Chris Peterson, and for my heat transfer project, I decided to measure the temperature rise inside of a car that is parked and being heated up by the sun. The solar heating of a car is from direct sunlight, and what happens is even in low temperatures, the sun will radiate on the car, and that will cause the inside of the car to heat up. Factors of this heating include the elevation. The higher you are, the less the sun's rays have to penetrate the Earth's atmosphere, and so you get more radiation, causing higher temperatures. The time of day, which the angle of the sun is important as to how much is being radiated on an object. The outside temperature has little effect, but some. And then the color of the car. Obviously, as we know, a black car will have a much higher absorptivity than a white car, which can reflect more radiation. The inspiration of this project came from the website heatkills.org, who claims that within 60 minutes, the inside temperatures of a car can reach dangerous levels. They claim that within 60 minutes, a car's temperature difference could be 40 degrees higher than when it was first parked. This can even happen in a mild temperature of 70 degrees and typically happens midday. So how exactly does it occur? Well, it occurs in two different but similar ways. The first is the sun will radiate on the top of the car. That heat from that surface will conduct through till the inside of the surface of the car, which will heat the air inside of the car. Then there will also be penetration through, as the next slide shows, through the windshield of the car and radiate on the interior of the car. If you have a black interior, which is pretty typical for most cars, or a dark interior, you will have a lot more heat convecting from those surfaces to the inside air of the car. So my actual experiment was done with a 2015 Honda CR-V. It is white, just like the one depicted here. The interior is black. I started this at around 11 a.m., which was okay because the sun's most intense times are typically from 11 to 3 p.m. I tested it for 1 hour, taking temperature recordings every 20 minutes. The placement of the temperature probe is very important, and I will go through some other observations, but I strategically put it here, right here, on the inside of the car, obviously, and in the middle, because that is about where a child's head would be. And so I feel the most important temperature to understand on the inside of a car is if you left your kid in the car, what temperatures are they going to be feeling? Before I started, I ran the car so that the AC was on and got the inside of the car to approximately 65 degrees. So in my results, I started at 65.1 degrees Fahrenheit. Every 20 minutes, I took a recording. We had a step up of about 3 degrees in the first 20 minutes, so not much. Then after 40 minutes, we went up to 75.6 degrees, so we went up another 10.5 degrees. And after 1 hour, the temperature inside increased by 23.7 degrees, which is pretty significant, but not quite the 40 that Heat Kills had said. My observations were so that as sun radiates through the windshield and heats up the black dash, I found that the heat up here was much more significant than in the rear of the car. This also is kind of why I placed it here, the temperature probe here, because it was kind of towards the middle, and I didn't want these ridiculously high readings up here because they were located just there. It was also important to understand that along the top of the car here, it was very hot. compared to the bottom of the car on the floor here. I've noticed that after I take my dog out to play during the summer, she hops in the car and then lays on the bottom of the floor, and I thought, well, that's kind of weird, must be cool or something. And in fact it is. As I put my hand down there, 60 minutes into my research, it was much, much cooler at the bottom than it was at the very top. So is it unsafe to be in your car after 1 hour? Now, during this experiment, it would have been pretty uncomfortable considering temperatures got upwards of 88 degrees just in that spot where I put the temperature probe. Anywhere else was much hotter. And I think that I didn't know the exact parameters that Heat Kills had done their experiments, and so maybe they used a black car, and maybe they had different conditions in the day, so it could get much higher. And I do believe that within an hour, a car can be dangerously hot, especially for children. But even if it's cool or it's nighttime, don't leave your kid in the car, obviously. And that was my project, and I learned a lot from it. Just things to improve would be to run several tests, use different temperature probes, and try different colored cars to get more accurate readings in different situations.